Hi, welcome to a PSL Demo Day. We're here today with Maia Sosa Kapur. She's a mathematical statistician with NOAA. She's helped develop an open source package called JABBA, which has been useful around the world in fisheries management. Maia, so good to have you with us today. Yeah.
Yeah, thank you so much for the invitation. So I'm Maia Sosa Kapur. My job title is Research Mathematical Statistician. I was mentioning earlier to Jason, so I work for NOAA in the Office of Fisheries Management, and my headquarters focuses on Alaskan fisheries, but I'm physically based in Seattle. And so basically, I will tell you a little more about what my job entails. But the point of today's talk is to really talk about this product we created called JABBA, which is an open source R package I developed with two collaborators. And it fits what are called surplus production models for data limited fisheries. So I know that it sounds like most of the audience here are economic folks. You'll actually recognize the model form that we use for this application. But I'm not going to go too heavy into like technical details on the model, really just focusing on some lessons learned. So I'm advancing the slide. And if anything goes weird with the presentation, just interrupt me or let me know. So just a little background of kind of the system we're working in. In the US, fisheries management is governed by a law that was signed in the 1970s that's called the Magnuson-Stevens Act. And that requires that our fisheries be managed scientifically and tasked the National Marine Fisheries Service, so who I work for, with achieving this task. So folks like myself are in charge of producing assessments every year that say, hey, here's the status of US fishery stocks, on a stock by stock basis. And that's going to inform how much catch we can take out of the water in a given year. So basically trying to avoid the tragedy of the commons problem that Weston is investigating. And so how do we do this? Fisheries population dynamics has a very long history, even before US was the country that it is today. European nations were thinking about, how do we manage these fishery stocks? And generally, this requires us to have some record of how many fish we've caught, ideally for several years, some idea of the ecology and biology of the fish species, and the ability to put this information together into statistical models. So depending what part of the world you're working in, any one of these three components might be easy or hard to come by. So in the US, NOAA spends hundreds of millions of dollars each year simply collecting data on the ecology and biology of fish species each year. So these include things like how quick the fish grow, where they're spawning, how, on average, how much they die, and how many of them seem to be in the water at a given time. And of course, nowadays, a big thing we're preoccupied with is climate change. So, even before we talk to the fishermen, even before we open like an Excel file, we are really, really curious and spending a lot of money in understanding, the basic ecology of these populations. And so that advantage, that privilege really mostly applies to wealthy fisheries in the wealthiest nation. So most places around the world absolutely do not have the privilege that we do in the US. And even places in the US that, maybe only have recreational fisheries or populations that aren't really heavily exploited, they also don't get a lot of taxpayer money to do these investigations. So I say up front that as someone who works on Alaska fisheries, we get, totally the biggest slice of the pie in terms of federal budget because we catch pollock, cod, Pacific Ocean perch, all these extremely high value billion-dollar fisheries. Whereas in your part of the country, either the Gulf or the Southeast Atlantic, people have a huge cultural identity with their fisheries, and there's so much recreational fisheries, but the dollar value is not as high. And so we're often making guesses about, okay, they seem to grow between this big or that big, or they're a lot like this other species we manage in the Northeast Atlantic. And so you can imagine, I'm kind of getting ahead of myself, but you can imagine there's a lot more uncertainty in those fisheries for which we don't have the taxpayer money to go out and get, great information. And so in our field, we refer to those fisheries as data poor or data limited. So there's really only an uncertain record of how much we might have caught, very limited information about the stock's biology, and importantly, a minimal capacity to build and test models of, statistical models of the population dynamics. So I'm sure you've encountered this in your work. It's great to build a tool, but if you want to deploy it in especially regions that are less privileged, they might not even have the personnel that understand how to implement and interpret those models. So all of this together was really what inspired my team and myself. So this is our little 3-person team. It includes me, my colleague Felipe Carvalho, and our other colleague Henning Winker, who is based in Germany. He loved this project so much that if you Google him, you'll see this hideous Photoshop job of him in JABBA. So he was very passionate about this project. Our simple goal when we started out with JABBA was to develop a reproducible, transparent, and open source framework that could help people evaluate their fishery stocks in the absence of a lot of that really expensive data. And for many of the fisheries that we're talking about, the big limitation aside from the data is building models that can run easily on their own computers and that they can understand. So we really started with this mentality of we want to make it easy for them to do their jobs. So in the next 2 slides, I'm going to give a really brief overview of the technical underpinnings of this model. If you're interested in more information, I encourage you to read the papers. You guys are economists, you're all smarter than I am, so you'll understand this just fine. So the first thing to understand is that JABBA is based on one of the oldest population models there is, which is called the surplus production model, also known as biomass dynamics model. It's been implemented for decades. I actually was exposed to this when I took Intro to Economics as an undergrad. I heard about that first before I went into fisheries. So you've been exposed to the Schaefer curve. So the idea in the fisheries application is that a fish population has an intrinsic growth rate that results in some amount of extra fish growth happening each year. That's what's on the y-axis. And that varies depending on the population size, so the x-axis. So we like to keep the population at or close to that optimum size so that the productivity is maximized. So in order to get that information and construct this curve, we need some concept of the growth rate of that population and about how big they are at a given time. So you can see how information about their biology and ecology become important, but we don't necessarily need the most nitty-gritty details. Like, I don't need to know where they're spawning to be able to get an estimate of what their growth rate might be. The second thing that JABBA leverages is Bayesian statistics. Hopefully you're all familiar with this, but it's a philosophical branch of statistics that allows us to incorporate prior information or guesses about what certain values might be during the model fitting process. And the advantage, especially for the fisheries application, is it enables us to get estimates that reflect our uncertainty about those key population processes. And that's very important when we're working with a very simple model type, because ultimately the values that come out of these models are used to make management decisions. So a manager is more empowered to make a more or less conservative decision if they have an idea what that envelope of uncertainty looks like. And so we're going to see some figures that represent this. So we took those 2 long-standing concepts, the surplus production model, Bayesian statistics, and we combined them inside an R package that's been hosted on GitHub for a while now. So that was in 2018. We called it the original JABBA package. We published a paper at that same time that describes the mathematical and estimation properties of JABBA, and there's a few case studies in there. Since then, we've continued to maintain the package, and we actually released a new version called JABBA Select. And this enables users to incorporate more detailed information about actually how the fishery is behaving. So Weston, you might want to check that out if you haven't already. It basically allows us to say maybe certain fisheries are targeting different aspects of the population, and it's kind of like an incremental improvement over the original JABBA package. So really that package, almost more so than the paper, is the star of the show. We had 2 guiding principles as we built it. The first was that we wanted to make the users' lives easy and help them do their job. So what that means is that we included a logical set of flexibility features that aligned with what we had seen through our consulting work. Often federal employees act as external reviewers for international fisheries. So we said, these are really the key things that these people need to be able to do. And we are going to automate all of the boring tasks for you. So the tables, the graphics, and the ability to conduct forecasting, which is also something that most fishery management agencies need, because there's typically years go by before a stock is reassessed. So we want to be able to have them instantly put in a few catch values and project what they think their fishery might look like. This map, it's actually already a little bit out of date, but it's showing where all over the world JABBA has been used. And within 2 years of the launch of that paper, we had almost 30 stocks worldwide that were using and managing their fisheries using JABBA. These goofy little graphics down here are some of the species that it's been used for. So we're not just talking about obscure reef species or some trout that, you know, your grandpa catches and you've never heard of. Some of these are very, you know, valuable fisheries, popular sushi sushi species. But because they are exploited in the high seas by many countries, there's not that tax structure or scientific infrastructure to go out and get the data we need. So that's kind of this interesting gray area where the fishery itself is actually high value, but there isn't the political, you know, ability to get the information. So we were very, proud of this project. And like I said before, I think it being in the R package framework is really a big part of the reason why we've had this success. I'm going to go through some lessons we've learned about, you know, maintaining and building that structure. But just want to highlight that this framework is really having a tangible impact on the conservation of exploited populations worldwide. So in this last little bit, I'm just going to share some lessons that we've learned that hopefully are applicable to anyone else that's building open source software, especially software that's being used to inform management decisions, which are, you know, of course, different than just academic exercises. The first thing is about documentation. So I think of documentation as coming in two forms. There's hard and soft documentation. So a hard document, in my view, is something like a peer-reviewed publication, has all the inner workings recorded and written down. And the advantage to that is it can be used also to track citations over time. So I forgot to mention this in my little brag session earlier, but the JABBA manuscript has been on the most downloaded list of the journal it's in for 5 years. So this is something that people are citing and, you know, referring to. Soft documentation are things like vignettes, you know, for your R code, and things like your in-code annotations. I think any of these, you know, types needs to be done with excruciating detail, because if there's a line of code, just guarantee that someone's going to ask a question about it. And I really wouldn't recommend releasing software, especially that you think might be used pretty extensively, without a hard document. There's really just no substitute for that peer review process, you know, having other people's eyes on it. Related to that, you absolutely must simulation test your package. So this is different than just thinking of a couple, you know, unique use cases and applying it. You really need to demonstrate the sensitivities, limitations, and uncertainties of the system that you're providing to the public. This also ensures that your code is truly as flexible as you think it is. I find so many papers, you've probably had this experience too. You read an awesome paper and they're like, oh yeah, the code's open source, it's online. You're like, yes. And you go there and it's really just a big wrapper function for what they did in the paper. And if you change one or two inputs, the whole thing totally breaks. So don't be that guy. And that brings us to our next point, which is responsiveness. So if you've, you know, done this before, even if you've just released code and said, hey, colleague, feel free to check it out, you have learned that maintaining anything online can quickly metastasize into a full-time job. So, you know, when JABBA first came out, when the paper was first released, I was getting emails about 3 to 5 times a month from all over the world of people being like, hey, I got this weird error. Hey, you know, what does this mean? Basically asking for help. And the thing we have to recognize, especially if we're developing tools that are designed to benefit people that haven't had the privilege of advanced training, you know, growing up in the US, always being around computers, there's maybe going to be times when they just have a very simple error, like, you know, you need to install this package first, or you're missing this thing. And that's kind of part of the responsibility that we take on, you know, when we release these to the public. So, you know, we don't need to have like this 5-year plan perfectly laid out right away, but just think carefully about who might fit best into the maintainer role in the near term. Something we really wanted to do before the pandemic was get funding to go down to Latin America, which is a heavy user of our product, and do trainings with them. Many, you know, I speak Spanish, many of our colleagues speak Spanish. It'd be something really easy for us to get money for and go help out. Just didn't work out. On a lighter note, especially if you're working on GitHub, think carefully if you want to encourage users to submit issues or submit pull requests or both. There's pros and cons to each. So just have a game plan. Don't post it and then, go on sabbatical for 5 years. Depending on your employer, there might be legal considerations you need to think about. This is, really applicable if you're a federal employee. Certain management systems, in fisheries have different definitions of stock status. So if you have built software that, provides quantities, be very, very explicit, in the code and in your documentation about what this quantity actually means. Like if I say maximum sustainable yield, that means something very different in the US than in Canada and different in Brazil. And so I would hate for there to be a lawsuit because someone said, oh, your package said MSY, but it meant something different. So just think carefully about some of those regional differences and legal considerations. Give as many talks as you can to spread the gospel, spread the message of your package. And this also is kind of a nice way to get a little bit of gut check on, if the tool is useful, if people find the plots useful, that sort of thing. The last point, which I think kind of goes for a lot in science, is to think small. So when we go out and build any project, we have this initial set of goals or tasks that we want that tool to be able to accomplish. And anyone who's been through peer review knows that the world has a tendency to ask us for more. Make it do this, make it have this feature, make it have my pet interests. And you end up with a Swiss Army knife package that is bloated, has version confusion, and now you have no time because you're maintaining this monstrosity. When we got inspired to build JABBA Select, which was kind of that incremental improvement over JABBA, we wrote a completely separate paper, built a completely separate package, and really kept them apart from one another so that people could still benefit from the original, so that it was kind of pure, so to speak, and they weren't, reading the paper and then going to the GitHub and finding this totally different thing. And it made our lives so much easier because people were able to really tell the difference. Great. So thanks so much for your time. I kept that short. I'm more than happy to take your questions now. And then here are the citations for the original JABBA paper on top and then JABBA Select on the bottom. Thanks.
Maya, thank you. And I kind of how you wrapped up talking about open source and how to do it correctly, I think really touches on what we've tried to promote with the policy simulation library, which is having that good documentation, having that version control, having active maintainers. Each of those, though, comes with its own challenges. Like, for instance, maintenance is not something that typically is kind of the sexy thing you can sell to funders. Going and giving talks incurs its own set of costs as well. How have you managed that with JABBA? And in particular, like I noticed a lot of use cases in South Africa. Did you have some of those training sessions or have specific outreach? And how successful was that?
Yeah, great question. So part of the reason South Africa was really on the radar, well, there's two big reasons. The first is at the time that we published JABBA, Henning, who is German, he was working in South Africa. And they are like a textbook example of kind of this intermediate wealth nation. They have scientists that manage fisheries, but no research vessels, so no idea what's actually going on in the water. So they were kind of our guinea pig for a lot of these things. And we did do some training, not in person, but virtually with scientists there. I think it's just a fact of life that the resource, meaning the personnel, your time, your availability to maintain these things is going to ebb and flow. What I've been so grateful for is that we went above and beyond, I'm kind of bragging, but I think in making the hard document, the peer-reviewed publication, excruciatingly detailed. Like there's very little that someone could ask that is not in that document. I know there's often this kind of, oh, I just want to publish, I just want to get it out there, but you will save yourself so much time in the future if you can say, you know what, reread section 3.7 and that will answer your question versus, writing off a long email every time. So, it's something that I think, especially if you're building tools that affect managed resources, there is money out there if you're interested in, applying for grants or federal funding. But You just kind of have to decide to, this is my hard limit.
Mhm. Now, also another question, just in terms of the users, is it always being used by fisheries managers, or do you have other researchers who are using this model, be they students or other researchers?
I was
Yeah,
just
it's
going to ask that question too. Sorry.
Oh yeah. Yeah, it's been actually pretty good mix. So, obviously there's like two tracks that it most popularly gets used by. The fisheries managers actually don't show up so much in our citation because it's often like gray literature that comes through. They're in some ways our power users and they use it for what it was designed for, producing quantities, very heavy international use for that. But we do get a ton of academic interest. Obviously, people like Weston working on, oh, I'm curious about how this dynamic works out. Like, why reinvent the wheel? The code's there. It's a Bayesian framework. I should have mentioned it's in JAGS. If you guys are familiar with the JAGS framework, that's what's under the hood of our software to implement like the MCMC chains and all that. So academically, there's a pretty robust user group. I think people often are curious. I've gotten emails from people in Saudi Arabia that are like, we just want to see how many of, red snapper are in the Red Sea and get an estimate based on this 5-year time series. And we want to use your model. I'm like, oh, that's awesome. So yeah, pretty diverse.
Yeah, very neat. And that's, I guess, a real advantage of putting your code out there on GitHub and having it be so accessible.
Yeah, definitely.
But where do people start? Like, ideally, you would. I was actually curious about flounder because I know there's a lot of flounder sold in South Carolina. I was like, come on, this has to be a huge fishery. But again, like it's the whole Atlantic coast, probably what we're getting. But I
Yeah.
Googled and I found Stock Smart from NOAA,
Oh yeah.
status management assessment and research trends. So if I'm able to find this already online, then maybe I don't need to use JABBA. Or is that how this works? Is you first just try to see if the data is available, or
Yeah, well, so yeah, that's actually great. Basically, if there is a stock that meets a fairly low bar of commercial exploitation, your local NOAA office, there's one in North Carolina, there's another one in Miami. They're in charge of managing it. So when you Google it and it goes and you get that hit on StockSmart, that is what those scientists have put together for flounder. I don't know. I don't think they're using JABBA for that species specifically, but I do know for black drum, which is another popular species out there, they're using JABBA Select. Earlier this year, I reviewed their assessment.
Hmm.
So yeah,
and
so basically, go ahead.
no, and that's one of those fish species I would also be curious about. Like, it seems hard to get that data because they're not commercially.
Exactly.
Yeah.
Exactly.
Okay.
Yeah, it was actually a really good time. I was sort of bummed because I had to do it virtually, but the main review was happening in Raleigh, I think. But yeah, they applied JABBA Select to the black drum population, and their data was really all over the place. It was like, oh, we interviewed these 5 dudes we saw on this dock, like down in Georgia, and then up here. But that's a perfect example because they have need to manage it because it's being exploited, but they don't have the money to do like a formal survey. And I think it was pretty cool what they came up with. Yeah.
And can we just go back to you had a slide on this. I was curious about, yeah, for me, again, like econ side, I might know some things, but then I see figures and I just can't read anything. But you said it's very user friendly what people will see. So you put some historical data and you get, yeah, this one. Yeah.
Yeah. Yeah. So these are screenshots from the case study from one of the papers we did. Basically, we can show you, this is more characteristic, this top left figure, of one of those like sushi species where it's like China's fishing it here and Japan's fishing it here and Taiwan's fishing it here. And then you just like dump all this data into one thing. So for many of those stocks, it's useful to see, okay, like who's catching really the most fish through time, where is most of our data coming in, that sort of thing. This figure in the lower left, this is pretty specific to fisheries management. It's called a Kobe plot. And it's basically a measure of how big the stock size is on the x-axis. You want it to be in the green. That means it's above that MSY, optimum point. And the y-axis is how hard we're fishing it. So if it's below 1, that means you're fishing it below MSY, which is good. You don't want to be in the red. that means you're fishing it too hard. So this is kind of like a quick shorthand way of seeing like what your stock status might be. And of course, the advantage of the Bayesian is you can check the posterior distribution of that quantity and really know, like, are we confident about that, or are we on the border, that sort of thing.
Thanks.
Yeah.
Yeah, any other questions for Maia? Well, I'll just say, Maia, I really enjoyed this, kind of combining some of my really favorite interests in fishing and in open source software. So really appreciated you being here today and learning about JABBA and its use cases and what you've learned about open source. If I could just add, I guess one final question is just in terms of like NOAA's view of having open source software like this, how much do they appreciate your work here in providing such a user-friendly package?
Okay, great question. So at the time that we published this paper, GitHub was actually on the gray to blacklist at NOAA. They were like, we don't know what this is. This seems horrible and risky. Like, no. And so we were using it with our like non-federal emails, non-federal accounts, because we knew, that it was fine and it was going to be legit. So 3 years later, they finally implemented like a formal agency-wide policy. And, you'll see oftentimes if you're on a NOAA managed GitHub site, it'll have like 10 pages of legalese at the bottom of the README. That's why. So they've really done a 180. They're much more open to it, and they're fully like supporting the open source thing now. It was a total pain when we started, but ask for forgiveness, not permission.
Yeah, well, that's great. Well, very good, Maia. Thank you so much for sharing your work.
Yeah. Thank you so much for having me.